ices all stuck together with bits of rock as well. So if we have a look, this is diagram here showing you the solar system in bits. So if we're right here, this is what they call the inner solar system here, which would fit in there with the outer planets. And we have a belt around there called the Crayford belt, which is where the comets that come back fairly regularly are thought to originate from. The one you would almost certainly have heard of is Halley's Comet. It comes around every 76 years. So it would be coming from here and travelling round the sun and back again. But beyond that, that whole section fits in here, and still within our solar system, we have this thing called the Oort cloud, where there are even more comets, but these are so far out that they take much, much longer to orbit the sun and come back again, if indeed they do at all. So we have two sections in the solar system where comets can come from. The more inner part here, called the Kuiper belt, and the outer part there, the Oort cloud. So this is what a comet might do. It starts off far from the sun, but as it approaches the sun, it will pass relatively close to it. So if you can see, this is the Earth's orbit, almost to scale. I think it would be even further away, really, than it would travel. It comes in close to the sun, and this is what happens when it does. It's heated up by the sun, and the ices in it melt and are driven off by the solar wind, and that's why comets have tails. The ices and the dust that are driven off by the solar winds reflect sunlight, and when they're close to the sun, we can then see them with their tails. Now, as it indicates here, on some comets, it's not always visible, you can see two tails. And the tails are always generally pointing away from the sun, because there's a stream of particles from the sun that blows them away. So wherever it is in its orbit, the tail is away from the sun. It's a misnomer in a way, because the tail isn't always following. It could be in front, depending where it is in the orbit. This is a massive crater in Arizona. It was formed about 50,000 years ago by a comet impact. And this is probably the clearest crater that there is on Earth, although the Moon, Mercury, other planets do have craters on them. But on the Earth, because they get eroded over time, very often they don't remain as visible as this one. But that's just over 1 kilometre across, that one. Gives it some kind of scale. So that was a pretty massive comet that hit there. One of the first good close-up pictures we had of comets was Halley's Comet in 1986. Some of you may remember it coming around there. I know they certainly opened up at Greenwich for people to see it at that time. They sent this probe called Giotto in relatively close to it, and it took that picture, which at the time they thought was marvellous. See one or two that I've got coming later, how things have improved over the years. You can see here that it's a bit complex, but they're trying to indicate where the dust and the gas jets out of the comet as it got close to the sun, and therefore formed its tail. Recent comets that have been good to see by naked eye. We haven't had any very recently. But in 1996, there was this one, Comet Hyakutake, and it had a massively long tail when it got going. Again, you can just about see that it's breaking into two, the iron tail and the dust tail. But the next year was Comet Hale-Bopp in 97. Not such a long tail, but it was a really clear comet to see at the time. And it showed its two tails very clearly. So, just coming up to date, before we get the demonstration going, 2014, well, the probe Rosetta had been up there for a few years already, but it was due to rendezvous with this comet, which I'm just going to call 67P, but the full name is there. And this was a unique event. They sent Rosetta the probe towards this comet, but it itself had this little lander on it that was stuck to the probe until it got there, called Philae, which when it went into orbit around the comet, dropped the probe down to try and get some information from the very surface of the comet itself. And I'll point out to you how much clearer this picture is than that 86 picture from Halley's Comet. So you can see how technology has moved on in that sense. So this was a picture taken from that little lander, Philae, light as it came in 2014 to land on the comet. So it's getting closer to the surface. There it is, it's landed, and you can see part of it, maybe part of its leg, I'm not sure there, as it landed. In fact, its landing didn't go that smoothly. It touched onto the comet and then it bounced up again. And it was in the air, it went up, a considerable distance, mile or more, and was up for a couple of hours before it came back down again, because the gravity was so low that it was a very, very slow bounce that it did. But anyway, it did land eventually. But it landed in a little crevice here, because the surface of the comet is very bumpy. It landed there, and that has proved to have been in shade since it landed there. And that was the massive problem, because it was going to get its energy from the solar light, and it didn't, and it switched off. So if you can see, that's the little area where it is. I'm missing part of my picture. But close up, can you move the... Yeah, that's better. This is this bit blown up. Can you see it's lying on its side with its legs in the air? So they got a bit of information from it when it first landed, because it was powered up at that time. But then after the power ran down and it didn't get any more sunlight, it didn't achieve any more after that. But this was the main probe. Rosetta took this picture of it in 2016, you can see there. Just before Rosetta itself was sent down to crash into the comet to finish its whole expedition out there. So there you go, that's Rosetta on its way down, only 10 miles above the comet before it landed. Okay, so we saw what the surface of the comet looked like. We now know from this from the Rosetta probe that the surface has this sort of very bumpy appearance. It's very dark, and that's what I hope I'm going to show you next. So I'm going to be out there. So you're very welcome to come out and stand around near the windows to watch. But if it's too cold for you, you could try and watch from inside.
Have you got enough light, or do you need a torch on you as well?
I've got that torch up there. Are people feeling they can see okay? I'm all right.
Is everyone happy? So what I will ask is, before she starts, if we can all get in, because I do need to shut the door, because we might set off the smoke alarm otherwise. That would be good.
Okay, so I'll just set myself up a drink. I've been talking too much, and I'm a bit thirsty there, so let's just get that going. So what I've got arranged in front of me are the ingredients for making a comet. In here is solid carbon dioxide, which is also sometimes known as dry ice. And this effect you might have seen on stage when they have kind of smoke effects on stage. Well, sometimes they do use smoke, but sometimes they use something like this. To the bag, the mixing bag. Okay, right, what else do we have? We have some bits of rocks and dust, so I'm substituting some sand for that. Let's throw that in. The very dark appearance, I don't know how well you can see, is due to carbon compounds on the surface. So I'm chucking in a bit of carbon. Basically it's coal dust. Very black. Which is the black appearance of comets. Now interestingly, comets also have what they call organic compounds in them. The sort of molecules that could be used in life, things like amines, those kind of things. So I'm representing my organic liver Yeah, very nice. Now the dry ice itself doesn't actually stick together very well, so I have to add water, which will be frozen by the ice, and which hopefully will stick the whole thing together. Now this is a bit of guesswork going on here, so you'll have to bear with me while I add the water and try and get it all to freeze together. God, it really smells of Liam Perrin.
I've done it.
I think, yeah, it's a bit too much organic in this one. Oh. This is the effect you get on stage, you see. It's water that you're seeing. Coming on.
Yeah.
Oh, yeah. Liquid oxygen, because our hospital we had a leak on the oxygen plant, so you've got -180 degrees wafting across. Oh dear, this panic.
There we are.
Oh.
And if you have a look, I don't know how well you can see, but can you see actually it really does resemble the surface that the pictures that they got. Oh, that's lovely. Thank you. Good idea. And you can see it out, what they call outgassing. You've got the ice is coming off as a gas there as it's warming up slowly.
Very clever.
Well placed Comet.
Or Liam Perrin's Comet.
Yeah.
That's a new
What
one
should
we
we
haven't
name this
found
one?
yet.
Yeah,
Liam Perry.
Oh, I really dug. Sorry, I overdid good. There we go. I mean, I'll leave it there and you're welcome to come back.
Everyone got a camera phone? Everyone take a